So hello coders, today I will discuss about the today's Leetcode daily challenge question sum of distance in tree. There is an undirected connected tree with n nodes labeled with 0 to n minus 1 and n minus 1 edges. Okay, you are given the integer n and the array edges where edge of I is ai and bi indicates that there is an edges between nodes ai and bi in the tree. Return an array answer of length n where answer of I is the is the sum of distance between ith node in the tree and all other nodes. For example, 1, the n is 6. Why? 0, 1, 2, 3, 4, 5. So n is 6 and the edges are 0 to 1, 0 to 2, 2 to 3, 2 to 4 and 2 to 5. Okay, so output is from 0 this is 8, from 1 this is 12, from 2 this is 6 and from 3 this is 10, from 4 this is 10 and from 5 this is 10. So this is the answer. For example 2, so n is 1 and edges is null. So output is 0. And the example 3, n equals to 2, so edges are 0 to 1 or 1 to 0 and the output is 1 1. You can check constants are 1 to n to 3 into 10 to the power 4 in math. So you have to do it in O of n complexity. You cannot do DFS and O of n square. Okay, so now we are describe it.
So the question is basically sum of distance in tree, and the question is there is an undirected connected tree with n nodes labeled with 0 to n minus 1 and n minus 1 edges. Okay, and you have to return the sum of distance between ith node in the tree and all other nodes. Okay, you can check you are given a undirected tree and the outputs are 8 12 6 10 10 10 and 10. So how the outputs are come, you can check from 0, from root node the distance is what, 1. From 0 the distance is 1, and from 0 in 3 the distance is what, 2. From 0 in 4 the distance is what, 2. From 0 in 5 is distance is what, 2. So 2 plus 2 plus 2 plus 1 plus 1, and that is 8. So from 0 the output is 8. You can check it's right now. So now we are checking from 1. Okay, so 1, then 0, then 2, then 3, then 4 and then 5. So from 1 to 0 distance is 1. From 1 to 2 distance is 2. From 1 to 3 distance is 3. From 1 to 4 distance is 3, and from 1 to 5 distance is 3, right? So you can check 3 plus 3 plus 3 plus 2 plus 1, 12. You can check this is right. So now we are checking from distance 2. Okay, so firstly this is 0 and then 1 and then 2 and then 3 and then 4 and then 5. So you can check from 0. You can check from 2 the distance of 0 is 1. From 2 the distance of 1 is 2. From 2 the distance of 3 is 1. From 2 to distance is 4 is 1. From 2 to distance of 5 is 1. So you can check 1 plus 1 plus 1 plus 1 plus 2. So 4 plus 2 is 6. So now checking for 10. Okay, so 2, then 0 and then 1 and then 3 and then 4 and then 5. Okay, so 3 to distance of 2 is 1. 3 to distance of 0 is 2. 3 to distance of 1 is 3. 3 to distance of 4 is what? 3 to distance of 4 is 2. 3 to distance of 5 is 2. So 2 plus 2 plus 1 plus 3 plus 2. So distance is 10. So that's how the distance is 10, and the distance for 4 is also 10 because it is same. You can check it, this is same. For distance of 5 this is also 10. So that's how all the outputs are come. Okay, so how how we do it. So in there first step we are doing pre-order traversal. Okay, so why pre-order traversal? Because in first step of pre-processing is to identify number of nodes that fall under the particular node includes. Okay, so how we doing the pre-order traversal? Just do the tree 2, then 3, and then 4, and then 5. Okay, just do the tree and do the traversal. Okay, so in the 2, the subtree distance are what? In 3 that is 1, in 4 that is 1, and in 5 that is 1. Okay, so this is complete. For 0, see distance is what? In 3 and it's 1, so 3 plus 1 that is 4, and there 0 to distance is what? 1, so 4 and 1, and for 0 the total distance is what? 4 plus 1 plus for 0 that is 1, that is 6. Okay, so that's how we clear the distance. And we are also doing the post order traversal. Okay, for post order traversal we are calculating the distance of each index with all other nodes. Okay, we are calculating the distance from each index with all other nodes. How we are doing it? In there just 0 and then 1 and then 2, 3, 4, 5. Just check for 0, this is what? 1. For 2 this is 1. Then for 3 this is what? 1 plus 3, that is 2. For 4 this is 2. For 5 this is 2. You can check we are doing for depth. For check we are doing the depth. How? Check it for 1 and then 2 and then 3 and then 4 and then 5. Check 1, then check 2, then check 1, then check 2, and then check 2. We are doing depth now, so that's we are doing post order traversal. Okay, so firstly we are checking, first we are doing pre-order, then we are doing post order for the traversal, and check the distance of tree to the root to subtree node. Okay, now what we are doing? So you can check the tree. We are in there for calculating the all sums. We are doing a algorithm. What the algorithm work? Just check distance of I is equals to dist root minus count of I plus count dot length minus count of I. Okay, that's how it's work. How it's work you can check. One thing, the distance of root is basically count of closer nodes. Okay, and this count dot length minus count of I is basically count of further node. Okay, so now how we do it? Just check for 1. Okay, for distance 1, distance I is basically 1. Okay, for 1 dist root distance root for 1 root node is what? 0. So in 0 the total is what? How we do it? In first time we are describe about it in post order traversal. Just this for 1 this is 1, then this is 1, and then this is 2, and then this is 2, and then this is 2. For 2 2 2, that is 6 plus 7 plus 8. For 0 8. So distance root is what? 8 minus count of I. Count of I is what? For 1, count of I is what? This is basically the closure nodes. Okay, so the closure nodes is 1, so count of I is 1, and plus the count of length. So total length is what? 6 minus count of I is what? 1. So for 1, 8 minus 1, that is 7, plus 6 minus 1, that is 5. So basically for 1, total is 12. You can check for 1, total is 12. Okay, so now we are checking for 2 right now. For 2, so for 2 the distance root is what? 8 minus count of I is what? Okay, so for true, how many nodes in current in under the 2? So 1 2 3, and for 2 that is 1, so that is 4. Okay, so 8 minus 4 plus 6 minus same count of I is what? 4. So for 2 this is what? 6, correct. And then we are checking for 3. We are checking for 3. For 3, so for 3 the root is what? 2. So from 2 the all sum is what? We are checking first time, because the distance of root, we need the distance of root. So for 3 the distance is 2, so 2 to distance is what? So 2 to, you can check from 2 the distance of its 2. 1 plus 2, that is 3 there, and then 1 1 1. So this is 3, so 3 plus 3 is also 6, is also 6. Is for, so distance root is 6 minus count of I is what? For 1 right now, so 1, and plus total length is what? 6 minus count of I is what? 1, so this is also 10. For now for 4 and 5, so 4 is also 10, 5 is also 10. So we are easily do it using pre-order traversal, then post-order traversal, and then the algorithm. Just dist of I is dist of root minus count of I plus count dot length minus count of I. So this algorithm is very important for do it. The time complexity is what? For pre-order traversal this is O of n, for post-order traversal this is also O of n. So now the time complexity is O of n, and the space complexity is O of n, because we are doing a vector and the tree, that is also O of n. So time complexity is O of n and space complexity is O of n. Now we are code it.
So in this code part, so firstly I use initial vector that stores the result for each node, and the node count stores the count of nodes in the subtree rooted at each node, and the vector of another set adjacent list. The adjacent list represent of the tree. Okay, so in the main function we are initialize data structures like adjacent list. For this code we are doing adjacent list, and the result that resize the end, and the node count that resize the end. So populate the adjacent list. You can check for adjacent list of I, we are doing another set int. Okay, so for all 0 and 1 we are inserted 1 and 0. This is the for the adjacent list we are doing easily. For calculating result using post order and pre order traversal. So rooted at 0, no parent initially we are doing. Okay, so in post order traversal 0 to minus 1, and in the pre order traversal 0 to minus 1 we are doing, and return the result. And now we are doing the post order and the pre order. For post order traversal, to calculate count of nodes in subtree at each node. Okay, so for we are just doing for child node adjacent adjacent list current node, and just checking child node is equals to parent node, then skip the parent node. Okay, and now we are doing post order traversal function for recursion code, and just do it. Okay, and the pre-order traversal for very easy, just check child node is equals to parent node count, just skip the parent node, and that do the algorithm that I describe it in the pen and paper. Result of child node is equals to result current node minus node count of children node plus node count dot size minus node count of children node. That's how we are doing the algorithm, and this algorithm is very important for doing the sum of all nodes in this tree. Okay, so now just pre-order traversal return, and that's how we are coding. So the time complexity is basically O of n, and the space complexity is basically O of n. I share my submission code in the description box. So thank you for seeing the video. Please do like, comment and subscribe. Okay, so run the code. So I'll discuss pass and submit it. Yeah, this is submitted.